Bryan Hennessy here. I'm going to take you through, so there's two parts of data logging and analysis, and they're just that, the actual capturing of the data that you want and the analysis of that data. The part of that I'm covering are the capturing of the data to show you how to capture the data you want reliably with Kvaser hardware, and then Maxwell will kindly go into the analysis of that data, mainly with CANLab's software. So I'm going to get started by showing you the general relationship of the two corporations and how our products play together. So on the bottom center of the screen, you have a typical CAN bus with, I've got 4 ECUs on there. It's really irrelevant. Could be 20, could be 2. We have the Kvaser data logger and interfaces. This is the primary interface to the actual hardware. We connect physically to the bus and bring the data to the applications, generally, in most cases, in the PC. The Kvaser Memorator is going to be the primary tool that I talk about. It's commonly called a data logger, and Kvaser Memorator configuration tools is going to be the primary piece of software I talk about. Both of those products from Kvaser interface directly with ATI, CANLab, and Vision. They're primary 2 products, software products. So that's the general configuration. So Memorator Lite and Pro, 2 versions of the Pro, those are the 3 products that I'll talk mostly about. The Lite we'll cover briefly, and then we'll move on to the Pro series. So the Memorator Lite is actually a true single channel device. It is as close to a plug-and-play device as we can make it. It auto-bods to whatever network you plug it into. It contains a 1 gigabyte circular log everything buffer on an SD card. So from the time you plug it in, it'll auto-bod and it'll start logging, if possible. It will log everything on the bus, and it has a second buffer where it will log up to 100 CAN frames both before and after a error frame event on a data bus, on a CAN bus. It is non-configurable, but the data is read from it and translated, converted in the same way data is read from the Memorator Pro devices, and that's using Memorator configuration tools. So I guess it's a little ironic that you have to use Memorator configuration tools to get data out of a totally non-configurable product, but that's the way it is. So just a name. So moving on, we'll talk about the Memorator Pro. It comes in two flavors, the 2-channel and the 5-channel device. And these units are basically identical with the exception of the number of channels and a little bit about the physical makeup of them. The 5-channel has a pigtail, if you will, that breaks out a single connector into 5 different DB9 standard CIA standard CAN 9-pin D connectors. The 2-channel is just direct connect of the 9-pin D connectors, both with a USB pigtail. So features of the Memorator Pro series, the two products in that series, they work as standalone data loggers running a custom configuration provided by Memorator configuration tools, of course. And they also act, I want to stress, as a standard USB interface, just like any other USB interface from Kvaser. So the USB CAN 2X or USB CAN 5X are duplicated. That functionality is exactly duplicated in the Memorator Pro series. So they really act as 2 products. They log from either 2 or 5 CAN channels simultaneously, using just 1 device, of course. Log data to an expandable SD card slot. I say expandable because that particular SD card has been tested all the way up to as big an SD card that's provided these days. I think a 512 gig. They take their power from the USB port or from the CAN connector. Obviously required to take the power from the CAN connector when they're in a standalone logging application. When I say a standalone logging application, I mean you configure these devices, you disconnect the USB port, you ship them to somebody, you plug them into a vehicle, you send that vehicle out, and they're logging data independently according to that configuration. So they do have LED lights that indicate the device status, including an SD full card, an error, or the LED lights will indicate that it's connected through USB to a PC as well. Galvanic isolation between the USB port and all of the CAN channels automatically time synchronizes the data transmitted and received across all CAN buses. So their internal clock will time synchronize all of the data that it logs with an accurate timestamp. Memorator configuration tools. This is the main thrust of what I'm talking about. This is the software configuration tools that configures both of these products as well as the Memorator Lite. So all of Kvaser software is free downloadable from our website. We sell hardware. It's free. It's USB. It provides, of course, the USB connection to the Memorator device. Creates a .khc file with the configuration information. That's the file on the PC. Configures filters and triggers in the Memorator Pro device. Those are the main things that you're configuring, are the filters and the triggers to be applied to the CAN data that you're logging. Allows multiple expressions for triggers and very complex trigger events. I think the triggering is one of the most powerful features of the Memorator Pro, and I'll talk and give some slight examples of the triggering coming up here shortly. These do support a DBC file, so you can load one or more DBC files into Memorator configuration tools, and that allows you to do your configuration according to signal and message labels as opposed to hex characters. There actually is no raw hex capability for setting filters and triggers in Memorator configuration tools. And I'll get into defining messages and signals here in a little bit. So it extracts and converts log files to 14, I think it's actually 15 different formats now. I should change that. So that's also a very powerful feature of Memorator configuration tools. Once you have logged that data, you can go into many different formats that are supported by a lot of different types of analysis software, including ATI's great software. And there's the actual screenshot on the bottom of what you'll see when you go to our website into the Kvaser.com downloads area and look to download Kvaser Memorator configuration tools. So a quick abbreviation of the process of using the Memorator in general. So you would download and install Kvaser drivers for Windows, assuming you were using a Windows device. You would download and install Kvaser Memorator configuration tools, the software I'm training on here now. You would connect your Memorator through a USB port to the PC. You would run Memorator configuration tools, and that's on the right, lower right. You see a screenshot of the window the primary window you see running Memorator configuration tools for a 2-channel Memorator. You would configure your filters and triggers that I show in smaller text than can be read. Just a couple of triggers configured there as an example. And then final process after catching the data would be to extract the files into, again, one of 14 different supported formats for analysis. So that's the abbreviated version of what we'll talk about today. One slightly important aspect is after installation, you will see in your Windows menu different versions of Memorator configuration tools. You obviously run the specific version for the hardware that you have. So in this case, I have a red arrow pointing to the Memorator Pro 2X HS, although a lot of my examples are showing Memorator 5X HS as the software I'm running in some of my screenshots and examples. And the obvious difference is when you see 5 channels, it's a 5X. When you see 2 channels, like in this screen, it's a 2X. So the first screen that I'm going to talk about is the general information screen. Pops up there, shows you the serial number, the firmware version, the driver number, things like that of the actual device that's connected. And this is just an informative screen. Again, I'll talk about all of the screens below that you see there on the right. On the lower left, you see the screen that comes up when you want to initially connect to your Memorator. So you're running the software, you've got the drivers and software loaded, you've plugged in your Memorator, you first have to connect to it, and this screen will pop up and show you hopefully the correct device to connect to. You will connect to it, and then its LED pattern will go into a circular pattern to confirm that you have PC connected and the software connected to your Memorator Pro. So connect the Memorator Pro, pull up this screen. I've already talked about general information. On the left, you see a list of the actual screens that I'm going to talk about, the configuration screens that I'm going to specifically talk about in this presentation. So next one down being bus configuration, then we got log configuration and defined messages and all that. So let's just move into those slides now. So I say bus configuration, CAN 1 and more. Each bus configuration screen is the same. You can configure all buses or channels on the device independently. So, or you can duplicate the screen on the lower right-hand side there. It's kind of hard to read, but you have a couple options: apply to all and set default for the channels. So that will allow you to configure, if you have 5 identical buses in this case to monitor, you simply you do one configuration, then you apply that configuration to all channels on that device. So you're checking, this is if you check inter-bus parameters, so you're checking the bus inter-bus parameters. The main things you configure is the bit rate, so you set the correct bit rate. Everything else, synchronous jump width, and the chip parameters and all of that is going to be on the scope of this presentation, but they will self-configure to a very good values once you select the chip rate. Current settings box there in the center right just shows what settings you currently are configured to for confirmation. And then we'll talk about the options in the lower right here in the next slide. So we have 3 options that are commonly checked here. You have the silent mode. Silent mode you can select, which disables that device from transmitting anything on the bus, so it's minimum intrusion on your bus's operation when you have silent mode checked. It's simply a logger. And there are some cases where you would want to put frames out onto the bus. There are some cases where you don't. Silent mode even disables error frame responses, so the device will not ever transmit on the bus. You have J1939 mode as a box you can check. J1939 mode simply configures some additional screens in Memorator configuration tools so that they display the arbitration phase, the CAN ID of the CAN frame is broken down according to J1939 rules. For those of you who are familiar with different CAN protocols, the CAN ID is broken down in completely different ways depending on what CAN protocol you're talking about. In J1939, you're almost always talking about a 29-bit CAN ID, and it's in J1939, again, it's broken down into priority, PGN, and source address. And you can, by selecting J1939 mode, it gives you additional screens later in Memorator configuration tools that you can actually set triggers and filters on PGN or source address. And then we have CAN-FD mode as the third option here, and CAN-FD mode is obviously selected if you're working with a CAN-FD data bus, and which it's not real popular, right? Well, it's not real commonly used right now, but it's certainly coming into the industry rapidly. We're just going to give all examples of standard CAN, what's called classic CAN at this point. We won't talk much about CAN-FD, but this device does fully support CAN-FD. It would change a few other things about this presentation, but we can get into that maybe some other time. Okay, so log configuration. Confirm that log everything is not selected unless you simply want to log everything like you would in a Memorator Lite. because this will disable all of the triggers at least. It won't disable the filters. It will disable all of the triggers and just log everything according to the filters that you have set up. You use FIFO mode here. If you would like to wrap around, so when your card gets full, it simply wraps around and starts overwriting the oldest log data on the card. It's usually not a problem. These cards are so big and log so much data that you usually don't have to worry about filling up the card. There is a spot on the Kvaser website where you can go to do a memory needs calculation, and it will estimate how big a card or how much time you have before that card is filled, before you have a problem that way. This screen also allows you to set the time you want to log after power is lost, up to 30 seconds with an internal power source. So if you have a power down event or something that you need to confirm, validate, this is a way to do that for up to 30 seconds. So defining messages. So as I said earlier in the presentation, you have to define a message in order to set triggers and filters according to that message, or set triggers and filters at all. You don't set them on raw CAN data. So if you don't have a DBC file that defines messages and signals, then you can define messages and signals in these two screens. Defining a message, it allows you to define it very much like a DBC file would. It allows you to name the message or the CAN frame. It allows you to define and name individual signals with that CAN frame. It allows you to set their length, their factor, their offset, so you can trigger on real values as opposed to raw data, and I'll get into that in the next couple screens. It allows you to set a Motorola or an Intel byte order, and signed or unsigned data as well. And here again, you would select J1939 protocol so that you could name messages according to PGNs. So if you are going to use a database and not define your messages manually, you would load the database with this simple database screen. It allows you to load databases and apply them to different channels if you have a 2 or a 5 channel device. It's a pretty straightforward screen for loading a database from your hard drive, and has the normal browse configuration, so you just go and load it up. Once the database is loaded, use the messages and the signals within that database in physical values or raw data, as I'll show. So for filters, we're gonna, again, one of the most powerful features of the Memorator Pro filters, the second being the triggers. So for filters, you can define up to 64 different filters per channel to be to be applied to all log data before the triggers. So you don't want to filter out your triggers. Be cautious of that. Filters include options again for J1939 formats, messages and signals, error frames, standard or extended frames as well, PGNs if you have J1939 mode selected, destination address. Filter types are pass, counting pass filter, and stop filter. I highlight those there. Pass and stop are pretty self-explanatory. Counting pass filter I'll go into briefly. So in a counting pass filter, in J1939 you might have a signal that you're interested in logging, but it's a 10 millisecond broadcast signal such as the DM1, and you don't want to log every one of them. You just want to keep an eye on that signal to see what state the faults are in on that vehicle. So you might want to log every 20th DM1. So you could do that with a counting pass filter you can configure. So you log every 20th DM1 that comes across the bus. So triggers, again, extremely powerful feature, very configurable in Memorator configuration tools, for very much used for debugging when you have a problem, when you have a vehicle that's exhibiting an intermittent condition or event that you really want to validate or understand and change. You would certainly want to use the power of the triggers. You use the triggers with the database labels for messages and signals, and you use conditions to fine-tune the triggers and use expressions to set data ranges. So I'll go into those a little bit. Each one of these screens on the right, when you're defining a trigger, will bring up another group of menus that allow you to further define that trigger in different ways. Depending on whether you've got J1939 mode selected or not, those screens will vary a little bit in the way they allow you to define and manipulate those triggers. And we have an example of a couple of trigger conditions on the bottom there that I've set up that are J1939 triggers that show physical values and ranges and all. Greater than, less than, equal to. So let's get into more of the triggers. So you build trigger conditions with raw or scaled values, and you trigger on signals within a specified range of values. So you can set up your trigger conditions according to, in the lower left there of that slide, equal to, not equal to, less than or equal to, so forth, so on. All of the conditions of the trigger. So you can trigger on a single value, greater than, less than, equal to, or you can trigger on a range of values. Sometimes it's very advantageous to trigger on a range of values, and because you don't know exactly what value you're going to come in, so it's difficult to trigger on an equal to situation because in a moving signal, it might not hit an exact equal to value. It just depends on the signal. Sometimes you can trigger on an equal to, later than, less than, but range is quite powerful. Add one or two expressions that combine up to 3 conditions to control triggering. So what I mean here is what you defined a few conditions, less than, equal to values to trigger on. You can put some expressions, and you can say, well, I want these 2 conditions both to be true in order to trigger. So in this case, I've got a RPM low expression, and my second expression I've got defined as RPM 1200 and trigger 1. So the RPM low, the RPM 1200, and the trigger 1 are individual conditions that I've defined previously in the trigger. So these are expressions, and you define what action you want to take on those expressions and how much post-trigger time you want to take that action. So you can start logging, you can stop logging, you can pause logging on different expressions. Again, expressions built on multiple conditions that you've defined. Then there's advanced triggers. Advanced triggers give you a couple of additional capabilities. They give you a capability of defining more conditions to trigger on, and advanced triggers are a separate checkbox in the configuration, so you would check that one independently. Advanced triggers actually give you one big additional feature, and that's a transmit list. So you can create a transmit list and set a transmit schedule. You can have an event occur. If that event occurs, you can execute a transmit list, and you can use a transmit list creatively to induce a vehicle into a certain condition to create what you want to log, or to put the vehicle in the condition that needs to be in order to capture the data that you're looking for. So I could go a little bit more into advanced triggers here. I'm not going to spend too much time on it for schedule purposes. So you'd use advanced triggers to, again, create advanced expressions using defined triggers, up to 8 different defined triggers. Create actions to be taken based on expressions, and up to 6 expressions, and the actions include start logging, stop logging, pause logging, activate or deactivate a transmit list based on those expressions. So we will move on from advanced triggers, talk briefly about scripts or TProgramming. So this is kind of, if you look at the trigger capability, the advanced trigger capability is the first 2 levels of using the Memorator, configuring the Memorator to catch your specific data. I would call TProgramming programmer's ultimate method or tool for catching your data. It allows you to have a C-like, write a C-like code that actually gets downloaded and flashed onto the Kvaser hardware that executes when powered from the CAN bus, and it's an event-driven language that allows you full control of the logging process and allows you to totally interact with the bus as well as log, so you can simulate a failing device and log the conditions that the ECU goes into to handle that failing device or handle that actual log condition. You can induce faults that you want to log, things like that. So TProgramming is a very, very, very powerful tool. I wanted to add here, if any of the audience ends up wanting to use TProgramming and wants to get some good examples to start, I've written a lot of TProgrammings that are valuable, and I'm glad to hand those out to whoever needs those as good starting points for using TProgramming. This is my favorite feature personally of the Memorator Pro, and I'm not even a hardcore programmer anymore. I'm just kind of a hacker with it, so it's really powerful. So once you get to the flash disk, the SD card, the lower menu there, flash disk management, you use this to extract your data log once you've captured your log data. So you have a couple options under there. You have log files and you have disk management. You can select under flash disk. It'll show you what's free and what's used on your SD card. This is the powerful screen I mentioned earlier. When you select to extract and convert files, this menu comes up, and you can select one of the many different formats to extract and convert files from. You can create, as examples, generic CSV or .txt files. You can create specific formats for ATI Vision, MDF4 formats, canalizer formats for vector, things like that. So you can format according to signals, and you can format you can format files just according to everything on the bus. You can format according to signals defined in DBC files. So the formatting option or the extraction option does allow you to use DBC files and extract according to the labels as well. A lot of third-party tool support based on this extraction scheme. A very powerful feature. Allows log files to be used by many different other common applications in the industry. So here's a couple of the formats, a list of the formats that are extractable, and I have red arrows pointing to which ones you would open. I think there's 3 of them there. They're supposed to be highlighted yellow, and they're not. Something that the application took out. But open these in Vision, the top 3, and then there's one that you open in CANLab to do a playback. I believe that brings me to my conclusion. Disk management. So you manage the data on the SD card through the disk management option. You check initialize, clear, test the SD card, that kind of thing. You can clear it out. You can get information on the SD card as well that way. The next slide brings me to my conclusion. Yep. So Memorator configuration tools is one option for filtering and logging data, and there are quite a few, including the TProgramming. It's available as a free download from Kvaser.com, as all of our software is, and it's needed to configure the Memorator Pro, extracting log files, flashing a T program. So if you write a T program, you need to select the script option within Memorator configuration tools and flash that compiled T program onto your SD card. Memorator Pro can be configured as a custom standalone diagnostic tool with filters, triggers, log everything, data extraction options to give you a wide range of applications for the Memorator Pro, including J1939 applications, CANopen, DeviceNet, Animator 2000, or pretty much any other custom CAN protocol that anybody's defined can be, you can use Memorator configuration tools to extract and validate and understand data and log data according to that protocol. That is my conclusion. I am now looking to hand it off to Max.
Well, thank you, Bryan, for that, for walking us through the Memorator and its configuration. We're going to spend a few minutes talking about CANLab, how to set it up, how it works with Kvaser hardware, and we're going to walk through the logical progression so that we can take the log files that you've recorded with the Memorator and replay them either onto a virtual bus or onto a bench test or into an actual vehicle. Okay, so I would like to mention that a free version of CANLab and a demo version of CANLab is available at the support.accuratechnologies.com website. You can get in contact with your local representatives if you're interested in a demo version, which will give you slightly expanded functionality over the free version, but both are available to you should you desire. So what is CANLab? CANLab is a multifunction bus analysis tool that allows you to send messages, replay messages, collect logs, view CAN traces, view bus statistics, and incorporates a C# scripting environment right inside the software to enhance your functionality in the field. So CANLab is a complete bus analysis tool. It allows you to access CAN, CAN-FD, and LIN networks. It will allow you to set up and record signals, messages, record and analyze data, check statistics, all within real time. And so the first thing you see when you open up CANLab is what we call a workspace. And the workspace is designed to look and feel like a typical Windows environment. And the workspace is the central location for you to view, record, send, and organize all of your CAN data. So here we see a live screenshot of CANLab. And like other Windows application, you have your common mouse-driven functions such as file, edit, view. These are all set up and designed to look and feel like a typical Windows 365 Office product. And just like all the other Windows applications, the menus, toolbars, and mouse controls are all designed to allow you to configure and manipulate the way you view and use CANLab. So underneath the main menu bar on the left-hand side is the navigation panel. And the navigation panel has several subpanes with device settings and utility managers. The first one we come across is called the channel manager. And the channel manager allows you to configure your various CAN hardware. And we support multiple CAN devices, ATI's proprietary CAN hardware, Kvaser CAN and LIN hardware, and Vector CAN hardware. This is where you're going to set up the hardware, define the hardware, set its baud rate. And it should be noted that this is the only part of the process in CANLab that must be done offline. After you've configured and set up your hardware, everything else can be done in real time while the application is running and you're collecting data. The next manager below is called the data source manager. And this is where we're going to add our calculated channels and our various monitors and our recordings. We support various level recordings from different utilities. So we support our own recorder file, obviously, text files, vector ASCII file, CSV data files, and the standard Kvaser log file as well, the ASCII2.txt. So on this slide here, we see a blow up of the navigation pane showing the various additions that you can make with your mouse. So under Channel Manager, we click on there, it comes down to a drop down, and you get to see the various hardware utilities. The same thing with the Data Source Manager. You bring it down, you can add your monitors and your recording files. The next manager pane we see is called our Database Manager. And the Database Manager gives us a visual representation of what databases are available to the CANLab software workspace. So you can reorganize, reorder, and add databases as you see fit. This can be done in real time. So even if you are in the middle of running a simulation or collecting data, if you need to add a database, you just go ahead and click on the Add Database button and search, grab your database and add it to it, and then you become available to decode any of those messages that you see coming through at any time. So here we see our typical workspace. We are going to add a channel. First thing we do is we come over and we set its baud rate. We can select whether it's normal or CAN-FD mode. We select a device. In this case, we're going to be using a virtual device. But again, you can see the drop down of the various hardware devices that we support in CANLab. Typically, when you have a device plugged into your laptop, CANLab will auto-populate with that, and you just have to select it. We can then go ahead and select the CAN channel based on how many channel opportunities you have. And then the next thing we do is we go in and select our CAN monitors. So in an instance where you have a multi-channel device, you can assign monitors to channels and channels to monitors, but they don't have to be linked. So you can have CAN channel 1 go to monitor 2 or CAN channel 2 go to monitor 1 as you see fit. And so here we're showing the workspace going through the process of adding a DBC file, adding our recording. So we go ahead, go to Add Data Source, select Recording, go out, scroll, and find the recorder file from the Memorator, add it to the workspace, go up and select the DBC file, add it to the workspace. And so now that we've got the hardware configured and we've got a DBC file added to the workspace and our recorder set to the workspace, we're going to spend some time talking about configuring the graphical portion of CANLab. And the first thing we do in our navigation pane is we go down to the Screen Manager Overview. So this gives you one of 3 different ways to select screen objects. So you can come in here and add scopes and replay and send windows, statistical windows, gauges, data item lists. So you get the ability to at any time add or remove graphical representation of the data that you're sending or receiving in the CANLab workspace. And since we're going to be talking about showing how a recorder file from a Memorator is replayed, the first thing we're going to set up in our workspace is a CAN replay window. So the CAN replay window, just like it says, it lays out the option of running one or more recording files, either together or individually, based on your preferences. So in the example that's on the screen, there are 2 recorder files. We have the ability to show the timing that we want, whether it's real time or a fixed time rate or a bit rate. We have the ability to show how often do we want to replay those messages, either singly or on an endless loop. We can apply triggers. So you can wait for an incoming message and then replay a message back based on your recording file. If we're when we're in the replay mode, we see a counter and a percent complete. That gives us a status to know how far in the data file we are in the recording. So to the right of that is your radio buttons or your action buttons. And these are going to affect the counter and the percent complete. So the first is a double arrowhead back. That resets the file back to the beginning. One arrowhead that sends it one message back. We have a play and a pause button. We have a stop button, which stops the recording and goes back to the beginning. And then, of course, we have an advanced button, which sends it up one signal. Next, we're broadcasting messages, but we want to see what we're broadcasting. So we will add a can trace object. So the can traced object is going to allow you to see all of your data that's being broadcast on the bus. And it has a lot of functionality. You can set up highlight fields so that when messages come in, it will highlight to help identify messages you're looking for. It has the ability to support fixed or scrolling mode. So you can either see a constant data stream or a specific set of messages or signals inside of a message. It's going to have identifiers to let you know what channel the messages are coming in on, what monitor they're being displayed on, whether it's being transmitted from you or received by you, the message ID, as well as its raw hex value. Now, if we have a database file, a DBC file, and we're in fixed scrolling mode, we have the ability to automatically see all of the decoded messages inside of the can trace object. So we can put it in fixed mode, click on the little plus signs next to the messages, and it will expose all of the signals within and give you a graphical detail of each of those signals inside of each message. So the can trace object also supports multiple protocols, CCP, keyword, and XCP, as well as J1939. Next, we're going to want, if you're looking for a more graphical or a more traditional way of looking at signals on the bus, we have a scope screen object. So the scope screen will give you the ability to have a graph plotted against the X timeline, which is time, and Y, which is going to be scaled based on the signal. And you can add multiple Y axes to the graph. So you can have several signals on multiple axes, all graphed in coordination with one another based on their timestamp. And if we go below that, there's a data grid that allows you to see a more tabular representation of your data, including signal values against a timestamp. And you can see where the data values align based on time as well. The scope is very customizable. You can change line colors, you can change line shape, you can change data point expressions in the scope screen object. Next, we have what's called a can send window. Now, the can send window allows you to define messages and broadcast them on the bus as you see fit. So this can be used for triggering modules to go into certain modes. Say you want to display, you want the module to respond with diagnostic codes. You can hit a broadcast button to set it into that mode, or a broadcast button that sends it out of that mode. You can unlock gateways, simulate controllers, as well as use it for exciting the module for diagnostic purposes. You also have the ability to group multiple messages together and send them out in tandem. And taking that one step further, CANLab has a embedded C# scripting environment, which will allow you to send out multiple messages, decode protocols, send multiple messages on a single keystroke. So if you wanted to send multiple messages to multiple modules, you could all hotkey that to one keystroke and have it sent up to broadcast to multiple modules. You can use this for node simulation. So if we receive a request for a specific module and that module is not present, you can write a script that simulates the module's response and broadcast it out on the bus. So the scripting environment really opens up the flexibility of CANLab to do a lot of hardcore development on CAN bus without a heavy financial investment on the user. Now we're going to look, now that we've got all of our managers defined, we're going to look at the graphical portion of CANLab. So the first thing we're going to do is we're going to add a CAN replay and a CAN trace window. Now CANLab uses a dockable Windows format to allow you to move the data to the most relevant position for your viewing. And then afterwards, right, once I've got my CAN replay window, I just drag over my recorder file into the replay window. And then just like every other Windows utility, I can expand the tabular data so I can see a better shot of it. I can set its timing mode and its replay mode. Once that's done, I go online, I press play on the radio button, and the CAN trace data starts to populate. I set that to fixed mode. And then because I've got a DBC file, I can open up and I can see the specific signals within that CAN message. And as I mentioned earlier, because CANLab does allow you to do a lot of things online, I can do the same thing with adding data. So I can add a scope object, which I'm doing here. I can drag a signal out of my DBC file. And drop it over into the recording. And it's automatically going to change the y-axis based on that signal. I go online, I hit play, and I can see the signal in my CAN trace window as well as my scope object down at the bottom. So as I mentioned before, I can come over and I can change a lot of the variables on here. I can change its color. I can change its data point. I could change it from digital to smooth or analog. So I can really set this up to look and feel however I need it to get the best effect on my workspace. And like other Windows utilities, I can drag and drop other signals into a running recorder or a running scope even while I'm online. So again, I go online, I hit play, I'm looking at data from my data list. I can go up and grab another signal. In this case, I'm going to grab a throttle position. I grab it, I right mouse click it, and I drag it down to the bottom. And as soon as I do, it automatically starts to display inside the scope. I don't have to go offline. It's all done in real time. I should also mention that most of these data objects have a built-in recorder that allows the user to record data while they're looking at it graphically. And this is very helpful if you're monitoring on your laptop a signal or a message coming in from the bus and you see an anomaly. You can actually hit a record and capture in real time while still collecting that data and displaying that data against other graphs or other objects. So if you're looking to get access to CANLab and are looking for a source for your Kvaser hardware, you can reach out to ATI. We've got 8 offices around the globe. You go to accuratechnologies.com. We've got our distributors and our offices listed there. You can just reach out to them and tell them that you're interested. They can set you up with either a quote or a demo copy or a free version of software so you can start working. And the key takeaway from this is that CANLab is a full-featured bus analysis software suite. It supports multiple protocols, it supports multiple buses, multiple hardware interfaces, and it comes with a complete integrated scripting environment built right into the software.